Mass versus weight. Understanding fundamental measurements. Mass and weight are fundamental concepts in physics that describe different properties of objects related to their quantity of matter and gravitational interaction. While often used interchangeably in colloquial language, they have distinct definitions and implications in scientific contexts. 1. Definition and measurement. Mass is a measure of the amount of matter in an object, typically quantified in kilograms, kilogram, or grams, g. It is an intrinsic property that remains constant regardless of an object's location in the universe. Mass determines an object's inertia, or resistance to acceleration when a force is applied, as described by Newton's second law of motion, F equals ma, where F is force, m is mass, and a is acceleration. Weight, on the other hand, is the gravitational force exerted on an object due to its mass and the gravitational acceleration of the celestial body it resides on. Weight is a measure of the gravitational pull acting on an object's mass and is expressed in units of force, such as newtons, N, or pounds force, lbf. Weight varies with the strength of gravity at different locations, such as on Earth's surface or in space. 2. Relationship to gravity. Mass is invariant and does not change with location, gravitational field, or external influences. It is a scalar quantity that reflects the total amount of material present in an object, determining its density and inertia. Mass is a fundamental property used to classify and compare substances based on their quantity of matter. Weight, however, varies depending on the gravitational field strength where the object is located. On Earth, weight is commonly measured using scales that account for the gravitational force exerted on the object's mass. The weight of an object on Earth's surface is approximately 9.8 meters per second squared, meter per square second, multiplied by its mass in kilograms, W equals mg. 3. Units of measurement. Mass is measured using standard units such as kilograms, kilogram, or grams, g, in the metric system, or ounces and pounds in the imperial system. Mass remains consistent across different measurement systems and is a fundamental property used in scientific calculations and engineering applications. Weight is typically measured in units of force, such as newtons, N, or pounds force, lbf, which account for the gravitational force acting on an object's mass. Weight can vary with changes in gravitational acceleration, such as in environments with different gravitational fields or altitudes. 4. Implications in physics. Mass influences an object's inertia and response to external forces, determining how it accelerates or decelerates in response to applied forces. Mass plays a crucial role in mechanics, dynamics, and materials science, affecting the behavior of objects in motion, energy transfer, and structural integrity. Weight reflects the gravitational force acting on an object's mass and is used to quantify the gravitational interaction between objects and celestial bodies. Weight is pivotal in understanding gravitational phenomena, planetary dynamics, and the effects of gravitational fields on objects and systems. 5. Practical applications. In practical terms, mass is used to classify and quantify substances, measure quantities in scientific experiments, and determine the balance of forces in mechanical systems. Mass measurements are crucial in fields such as chemistry, physics, and engineering for designing materials, calculating energy requirements, and assessing physical properties. Weight measurements are applied in everyday contexts for determining the force exerted by objects on surfaces, e.g., floor scales, calculating loads in construction and transportation, and understanding the gravitational effects on human activities and equipment. Weight considerations are essential in aerospace, maritime, and industrial applications where gravitational forces impact operational efficiency and safety. Conclusion. Mass and weight are fundamental concepts in physics that describe different aspects of an object's properties related to matter and gravitational interaction. Mass is an intrinsic measure of an object's quantity of matter, whereas weight is the gravitational force acting on an object's mass and varies with gravitational field strength. Understanding the distinctions between mass and weight is essential for accurate measurement, scientific analysis, engineering design, and practical applications across various disciplines, highlighting their foundational roles in physics and everyday life.